So looking at the question here, we've got triangle HJK, which is isosceles, HJ is equal to HK, and JK equals to the root of 80. Then we are given different details about the points, HJ and K. And as you can see here that we have the whole coordinates for H. We have a missing part of the coordinates for J, which is the X coordinate is going to be less than 0. And we have a missing Y coordinate here for point K. M, it tells us is the midpoint of JK, the gradient of HM is 2, and it asks us to find the missing values of J and K. I'm going to draw a couple of sketches. With a question like this, I think it helps just to put something down to start with, and just go, okay, what have we got here? Well, looking at this, I have an isosceles triangle where HJ and HK are the same. So my triangle is going to look something like that. JK is equal to the root of 80. I don't know the orientation yet of the actual image yet, of the triangle yet, but we'll look at that when we look at the coordinates. So that's generally what I've got. Now let's have a look if we did a coordinate grid. H is going to be at minus 4, 1. So let's just do another little sketch down here. And just approximately minus 4, 1 is going to be minus 4 on the x-axis, 1 is going to be slightly up, so it's going to be approximately there. So H is going to be minus 4, 1. And then we've got point J. J is less than 0, so J is going to be to the left-hand side of the y-axis here, and the y-coordinate is 15, so it's going to be up here somewhere. So I'm going to put a little marker up here and call that J, and that is going to be J. 15. And looking at my triangle here, I've got, if this was J and H, I've actually got my sketch here upside down. So where's K going to go? K is going to be 6K, so it's going to be 6 in the positive, and then K could be up here, could be down here, I don't really know, but it looks like if H is here, then K is probably going to be positive up here. So I'm going to put a little marker up here. It's not to scale, it's just a sketch, but it gives me some idea. My triangle is going to look something like that with these two lines of the same length. Okay, so what else do I know? Looking at this, it says that M is the midpoint of JK, so I can mark that point on here. This is going to be M. I should have put, this is K. This is M, it's the midpoint along there. So that's that bit done. And the gradient of HM, oh, so that's another line I'm going to have to draw on. So HM, so this line going through H and M has got a gradient of 2. Okay, so that bit's that done. Okay, so what can we do with the information and what can we work out? Well, going back to my original sketch here, if I was to put M onto here, so let's put that in green down here, M, and I was to join that line H to M, you can clearly see that that is going to be a perpendicular bisector of JK. So I can mark that on here, that's pretty clear. So if I know that the gradient of HM equals 2, then I know that the gradient of JK is equal to minus 1 over the gradient of HM. Because that's when you have two lines that cross, if one is perpendicular to the other, the gradients relationship is M1 is equal to minus 1 over M2. It's the negative reciprocal. So the gradient of JK is going to be negative 1 over the gradient of HM, which is minus 1 over 2. So the gradient of that line there, JK, is minus 1 over 2. Now I want to focus just on this segment here, JK. So I'm going to redraw it, just give myself a little bit more space down here. So I've got J and K. And I'm going to form a triangle off of this. Now I know that the coordinates for J are J15, and I know the coordinates for K are 6K. And I also know that the distance jk is root 80. Now the gradient of jk, we've already worked out to be is minus 1/2. The gradient, as you know, is change in y over change in x. So I can use my coordinates here for j and k to write an expression for my gradient. So with my gradient here, okay, I've got change in y. So that would be k minus 15. That's the k coordinate, the y coordinate of k minus the y coordinate of j. Over the change in x, which is going to be 6 minus j. So that's the difference between the two x coordinates. And I know that is equal to minus 1 over 2 because I've already calculated that in the first part of the question. So let's rearrange that equation. I've got 2 bracket k minus 15 equals minus 6 minus j. Let's expand that out. Get 2k minus 30 equals minus 6 plus j. So j is equal to 2k minus 24, and I'm going to call that equation 1. I'm going to use that shortly. Now looking again at my triangle, I know this is right angled because that's how I've constructed it. So I can actually look at the distances as well. I can form an equation here using Pythagoras' theorem. I know what this distance is, I know what this distance is. This is the change in y, this is the change in x. So I can write another equation here whereby I have the root of 80 squared is equal to my change in y, which is 6 minus j squared plus 15, or k minus 15 squared, or why have I put j minus k minus 15 squared. So I've got my change in x and my change in y. So let's work this through. I've got root of 80 squared, which is just 80. I expand out 6 minus j squared. So that's going to give me 36 minus 12j plus j squared. I'm going to expand out k minus 15 squared. So that's going to give me k squared minus 30k plus 225. And now let's tidy this through. I've got 80 equals j squared minus 12j plus k squared minus 30k. So leaving the algebraic terms at the front. 225 take away 36. And in fact, I can also take away 80 from both sides at the same time. So I'm going to do 225, take away 36, take away 80 will give me 131. So I've got an expression here, doesn't look very pleasant, but I'm going to call this equation number 2. And what I can do is I already know what j is equal to in terms of k, so I can actually substitute that in. So I can substitute 1 into 2. So I've got 0 equals 2k minus 24 squared minus 12, 2k minus 24, plus k squared minus 30k plus 181. That's horrible. Let's work it through. Let's expand it out, see what we get. 2k squared is going to be 4k squared. And then I'm going to have minus 4896k. And then plus minus 24 squared is plus 576. That's the first one expanded. Then I'm going to do minus 24k plus 288, I think, minus 12 times 24, 288, plus k squared minus 30k plus 181. Tidy this up. It looks horrible at the moment. So we've got, what have we got here? We've got 4k squared plus k squared. Well, that's 5k squared. We've got minus 96k minus 24k minus 30k. So that works out to be, I think, minus 150k. And then I have 576 plus 28 plus 181 gives us 1045. What I have here is an equation where there's only one unknown, k. It's a quadratic. So can I solve this? Well, actually, looking at it, these are all multiples of 5, so let's just make this a little bit easier. Let's divide by 5. So 0 equals k squared minus 30k plus 209. Now, you could use the quadratic formula, or you could actually spot that actually this is equal to 0 equals k minus 11, k minus 19. So k equals 11 or 19. Now, that's the k. I need to work out my j and then find out which is the best values. So I can substitute now this back into one of my expressions. I'm going to sub into equation number 1. So sub into 1. So I've got j equals, now my expression was, I think, 2k minus 24. So j equals 2 times 11 minus 24, which is equal to minus 2. Or I've got 2k minus 24, which equals 2 times 19 minus 24, which is equal to 14. Now, in the question, it says that j is less than 0. J is less than 0. So 14 is not valid. Cannot be. So my solution is j equals minus 2, and therefore k equals 11. That's a lot of work for 6 marks. But just to do a little review through, basically what we do is we look at the information that they give you. You should understand that you're going to be working on gradients. Form the diagram. Use the gradient for one line to work out the gradient of the other line. Then form an equation using the change in y over change in x. Get an expression in j and k. Now we could have arranged it so k was on its own, but it just looked neater to have j on its own because it was the singular of the two terms. Then we form a second equation using Pythagoras' theorem, and then work that through, and then we do a substitution to find our expression purely in terms of k. 2 solutions because it's a quadratic. Substitute back into one of my equations. Let's go for the simple one up here, and then that gives us 2 different values. Refer back to the information in the question, and that tells us that one of the solutions is valid, one of the solutions is not valid, and then we have our answer.